Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz AIMAN bin HASBULLAH. So today I will present about introduction of the SCADA system. So SCADA is a short form for supervisory and data acquisition. So SCADA is a control system architecture that is involve computer, network data, communication, and graphical user interface for high-level supervision of machine and process. So SCADA is a technology that enable user to collect data from one or more facility, and it allow user to send a limited control instruction to those facility from far away. Next is the SCADA configuration. So each SCADA system will have a different SCADA configuration because SCADA configuration will depend on a system and the requirement of the system. Each configuration of a SCADA system will consist of master unit and remote unit. The various of configuration that used in SCADA is one of the one-to-one SCADA configuration, star SCADA configuration, network and party line configuration. At the below of the slide, there are one of them example of the SCADA configuration, which is a network SCADA configuration. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Irfan Syafiq bin Muhammad Rosli. I will continue the presentation about the SCADA system. So, my topics is, I covered the topic about the SCADA architecture. First is architecture of SCADA. SCADA used for monitoring and controlling industrial process, infrastructure and facilities. The architecture of SCADA system typically consists of several key components such as operator, HMI, human machine interface, MTU, master terminal unit, communication and remote terminal unit RTU. So this is the example of SCADA architecture, which is start with the supervisory. The technology is SCADA to collect the database. Then it connect to the communication, which is GPRS, internet, radio, satellite or VPN. It can be connected by the wire or wireless. Then it move to the PLC or RTU and HMI. From the local control, it move to the sensor or actuators such as switch, machine or fan. Next is the SCADA major component and function. The first component is input-output device, I/O device. These devices are normally installed at field to collect signal and measurement. Then remote terminal unit RTU. RTU in a SCADA system play the role to scan and collect signal from I/O device and convert them to digital data. The next component is the PLC, Programmable Logic Controller. PLC is same as the RTU, which is connect to I/O device to obtain real-time signal and then transfer them as digital data to supervisory system. Next, communication network. Communication network is the link that connect everything together. This includes the connection between RTU or PLC and the supervisory system. Next is the supervisory system, the central system which transmit or receive and process the digital data from RTU or PLC. It acts as the brain to send out command to the operation. A supervisory system shall comprise of a database or storage server. And lastly is the HMI, human machine interface. Interface that used by operator to interact with the supervisory system to monitor and control the automation process. HMI screen shall consist of SCADA mimics, alarm, report and the trend for the analysis purpose.
Assalamualaikum, my name is NURFASIHah binti BAHARUDIN. Today I will continue the presentation and explain to you about the contribution of SCADA system. First contribution of SCADA system is improving the efficiency. SCADA help to optimize the power generation and distribution network by controlling and monitoring the components such as transformer and etc. in real time. Second contribution of SCADA system is compliance with environmental regulation. SCADA ensure compliance with environmental regulation by monitoring and controlling the renewable energy use in SCADA system. The third contribution of SCADA system is remote controlling and monitoring. It helps to reducing the worker for complete the task physically, and it also improving the safety for the worker. Next, the advantages of SCADA system. The first advantage is cost saving. It reduces downtime and cut costs by quickly identify the issue of downtime. Second advantages is a real-time data and analysis. It enables to keep an eye to an operation and helps engineer to make decision when something happen based on up-to-date data. The third advantage is a proactive maintenance. SCADA system allow for preventive maintenance measure and helping for anticipate the machine failure. Next, I would like to explain about the constraint of SCADA system. So the first constraint is security. Most SCADA system is connected to critical infrastructure and at risk of cyber attack. So the third constraint is the cost. SCADA system might be cost saving, but at first to build the SCADA system, it will cost you a lot of money because it's involving a significant investment on hardware, software, and etc. Constraint of SCADA system is operational confusion and security concern. SCADA system mostly use monitoring and controlling by remote. By incorrect user selection can lead to operational confusion and raise the security concern.
One potential or real application of SCADA system in power system is power grid management. The SCADA system in power grid management play a pivotal role in monitoring, controlling, and optimizing electrical power distribution and transmission. The SCADA system also collect the real-time data from substitution, power plant, transformer, and distribution line and powers inform decision making for operator. The key function of SCADA system in power grid are real-time monitoring, like continuous monitoring of grid component ensure seamless operation. The second, control and automation, such as enable remote control of switch, breaker, and transformers for efficient management. The third one is data analysis, like collect and analyze data to predict trends, prevent failure, and optimize grid performance. The fourth is fault detection and response, like rapidly identifies fault outage and respond to maintain system reliability. The practical application of SCADA system in power grid management is one, managing load distribution, like redirect power resource in response to sudden demand surge, preventing overload and blackout. The second is isolation of fault, like identify problematic grid section to minimize disruption in power supply. The architecture of SCADA system designed for power grid management have 9. 1. Sensor and remote terminal unit (RTU). RTU deploy across critical power grid point, measuring parameter like voltage, current, and temperature. And RTU also collect data and converting analog signal to digital for transmission. The second, data acquisition system. Aggregate data from RTU and sensor, ensuring continuous data flow, and it also acts as an intermediary between field device and the SCADA system. The third is communication infrastructure, like include protocol like DNP3, IEC 61850 or Modbus for reliable and secure data transmission. Then utilize medium like fiber optic cable or microwave link for connectivity. The fourth is SCADA Master Terminal Unit (MTU). MTU is core component retrieve, processing and storing data for analyze and control. Then it acts as the central hub for information exchange.
Next, human-machine interface. Provide real-time graphical representation and interaction for operator, display critical data, system status, and allow common input. Next, control center. Host SCADA server, databases, and operator workstation. Centralize space for data analysis, monitoring, and decision making. Next, historian and data storage. Store historical data for analysis, reporting, and trend analysis. Crucial for understanding past system behavior and future decision. Next, remote access and security system. Allow authorized remote access for monitoring and control. Implement robust security measure to safeguard against cyber threat. And lastly, integration for robust grid management. Enable real-time monitoring, control, and analysis for ensuring grid reliability, optimize performance, and facilitated quick response to contingency. Next, I will talk about how SCADA system works. First, data acquisition. The sensor measure parameter and the data collected by sensor is transmitted to remote terminal unit using wired or wireless communication protocols. Next, communication protocol. RTU act as intermediaries between sensor and the central SCADA system. They aggregate, pre-process, and transmit the collected data using communication protocol. SCADA system use communication networks such as internet, radio, and satellite connection to communicate with RTU and receive data. Next, processing and storage. The central SCADA software receive the transmitted data, it process and manage this data, performing the function like validation, scaling, and conversion into usable format. Process data is stored in database or historian system, enabling historical tracking, analysis, and compliance report. Next is human-machine interface and visualization. The SCADA system provides an HMI, which serves as an interface for operator and engineer. It displays real-time data, alarm threats, and graphical representation of the industrial processes. Operator use this HMI to monitor operation, identify threats, analyze historical data, and receive alert about abnormal condition. Lastly, control and automation. Based on predefined logic, control algorithm, or operator input, the SCADA system allow operator to issue command or set point to control device. Control action facilitate adjustment in process parameter, enabling optimization and maintaining efficiency in industrial operation.